minimum conductor size from the load side of the meter pan to the line side of the disconnect is specified in National Electrical Code Section 230.42 B2. That section states that the minimum conductor size shall be based on the rating of the overcurrent device protecting the circuit. The National Electrical Code provides tables with the minimum conductor sizes for various overcurrent device ratings. For example, a 60 amp overcurrent device requires a minimum of number 8 American wire gauge copper conductor. Therefore, the minimum conductor size for a 60 amp circuit breaker is number 8 American wire gauge. Using number 60 HHN conductor for a 60 amp circuit is acceptable because it meets or exceeds the minimum requirement of number 8 American wire gauge. The requirement for the minimum conductor size can be found in the 2002 National Electrical Code, Section 230.42 B2. It is important to always consult the most recent edition of the National Electrical Code and local amendments for the most up-to-date and accurate information. Electrical codes and standards are subject to change. Electrical work can be dangerous. It is important to take the appropriate safety measures and consult with a qualified electrician before performing any electrical work. Always de-energize circuits before working on them. Wear appropriate personal protective equipment, such as safety glasses and gloves. Ensure that you have a clear understanding of the electrical codes and standards applicable to the work that you are performing. The National Electrical Code specifies the minimum requirements for electrical installations. However, local jurisdictions may have additional requirements or amendments to the code. It is important to check with your local building department or electrical inspector to determine the specific requirements that apply to your area. The National Electrical Code, or NEC, is a comprehensive set of guidelines and regulations governing electrical installations in the United States. It is published by the National Fire Protection Association, or NFPA, and is updated every 3 years. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. The purpose of the NEC is to ensure the safety of people and property from electrical hazards. Compliance with the NEC is typically required by law, and electrical inspectors enforce the code during construction and renovation projects. When determining the appropriate conductor size for an electrical circuit, several factors must be considered. These include the ampacity of the conductor, the voltage drop in the circuit, and the ambient temperature. Ampacity refers to the maximum amount of current that a conductor can safely carry without exceeding its temperature rating. The NEC provides ampacity tables for various types of conductors based on their size, insulation, and installation method. Voltage drop is the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to a maximum of 3% for branch circuits and 5% for feeders. Ambient temperature is the temperature of the surrounding air or environment. High ambient temperatures can reduce the ampacity of a conductor, as the conductor will dissipate heat less effectively. The NEC provides starting factors to account for high ambient temperatures. In addition to the factors mentioned above, the type of load served by the circuit must also be considered. For example, circuits that supply motors or other inductive loads may require larger conductors to handle the inrush current that occurs when the equipment starts. The NEC provides specific requirements for motor circuits in Article 430. The NEC also addresses the use of different types of conductors, such as copper and aluminum. Copper conductors have a higher ampacity than aluminum conductors of the same size. However, aluminum conductors are less expensive and lighter than copper conductors. The NEC allows the use of aluminum conductors in certain applications, but requires that they be properly sized and installed. Grounding is another important aspect of electrical safety. Grounding provides a path for fault current to flow back to the source, which helps to protect people and equipment from electrical shock. The NEC requires that all electrical systems be properly grounded and provides detailed requirements for grounding electrodes, grounding conductors, and bonding. Overcurrent protection is essential for preventing damage to electrical equipment and wiring in the event of a fault or overload. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current when it exceeds a safe level. The NEC provides requirements for the selection and installation of overcurrent protection devices in Article 240. Wiring methods refer to the way in which electrical conductors are installed and supported. The NEC recognizes various wiring methods, including rigid metal conduit, electrical metallic tubing, flexible metal conduit, and non-metallic sheathed cable. Each wiring method has its own advantages and disadvantages, and the appropriate wiring method will depend on the specific application. Equipment installation is another important aspect of electrical safety. The NEC provides requirements for the installation of various types of electrical equipment, such as lighting fixtures, receptacles, switches, and appliances. These requirements are designed to ensure that the equipment is installed safely and correctly. In addition to the NEC, there are other codes and standards that may apply to electrical installations. These include local building codes, state electrical codes, and industry standards. It is important to be familiar with all of the applicable codes and standards before beginning any electrical work. The National Electrical Code, or NEC, is a living document that is constantly evolving to reflect new technologies and best practices. The NEC is updated every 3 years, and each new edition incorporates changes and revisions based on feedback from industry experts, code enforcement officials, and the public. It is essential for electricians, electrical engineers, and other professionals in the electrical industry to stay up to date with the latest edition of the NEC. There are several ways to stay informed about changes to the NEC. One way is to attend training courses and seminars offered by organizations such as the National Fire Protection Association, or NFPA, and the International Association of Electrical Inspectors, or IE. These courses provide in-depth coverage of the NEC and its requirements. Another way to stay informed is to subscribe to industry publications and online resources that cover electrical codes and standards. These publications often include articles, news, and analysis of changes to the NEC. The NEC is a complex and comprehensive document, and it can be challenging to understand all of its requirements. However, there are many resources available to help you navigate the code. These resources include NEC handbooks, study guides, and online forums. The NEC handbook provides detailed explanations and examples of the code requirements. Study guides can help you prepare for electrical licensing exams. Online forums provide a platform for asking questions and sharing information with other professionals in the electrical industry. When working with electrical systems, it is important to remember that safety is always the top priority. Electrical work can be dangerous, and even a small mistake can have serious consequences. Always follow the NEC and other applicable codes and standards, and take the necessary precautions to protect yourself and others from electrical hazards. One of the most important safety precautions is to always energize circuits before working on them. This means turning off the power to the circuit at the breaker or fuse box. Before working on a circuit, use a voltage tester to verify that the power is off. Another important safety precaution is to wear appropriate personal protective equipment, or PPE. This includes safety glasses, gloves, and other protective gear. Safety glasses protect your eyes from flying debris, and gloves protect your hands from electrical shock. When working with electrical systems, it is also important to be aware of the potential hazards of arc flash. Arc flash is a dangerous electrical explosion that can occur when there is a fault in an electrical circuit. Arc flash can cause serious burns, blindness, and even death. To protect yourself from arc flash, wear appropriate arc-rated clothing and equipment. The National Electrical Code is a critical resource for ensuring electrical safety. By understanding and following the NEC, you can help to prevent electrical accidents and protect people and property from harm. Remember to always prioritize safety when working with electrical systems, and consult with a qualified electrician if you have any questions or concerns. In the specific case of running conductors from the load side of the meter pan to the line side of the disconnect, the 2002 NEC section 230.42. B2 dictates that the minimum conductor size be based on the overcurrent device protecting the circuit. Since a 60 amp circuit breaker is used, the table within that section will show that a number 8 American wire gauge copper conductor is the minimum acceptable size. The use of a number 6 American wire gauge THHN conductor exceeds this minimum requirement, making it an acceptable choice. However, it is important to ensure that all other relevant requirements of the NEC are also met, such as proper termination and support of the conductors, as well as adherence to any local amendments to the code. Proper conductor sizing is essential for safety and reliable operation of electrical systems. Undersized conductors can overheat, leading to insulation breakdown, fire hazards, and voltage drop issues. Oversized conductors, while not posing a safety risk, can be unnecessarily expensive. Therefore, it is important to carefully calculate the required conductor size based on the load, voltage drop, and other factors. In addition to the NEC, other standards and guidelines may be relevant to electrical installations. These include standards from organizations such as the Institute of Electrical and Electronics Engineers, or IEE, and the National Electrical Manufacturers Association, or NEMA. These standards provide guidance on topics such as power quality, grounding, and equipment performance. The electrical industry is constantly evolving, with new technologies and techniques emerging all the time. It is important for electrical professionals to stay up to date with these advancements in order to provide the best possible service to their clients. This can be achieved through continuing education courses, industry conferences, and professional development activities. The safety of electrical systems depends on the knowledge, skill, and diligence of the people who design, install, and maintain them. By adhering to the NEC and other applicable codes and standards, and by staying up to date with the latest industry trends, electrical professionals can help to ensure the safety and reliability of electrical systems for years to come. The NEC is not just a set of rules, but a comprehensive system of safeguards designed to protect people and property from electrical hazards. Understanding the principles behind the code requirements is essential for making informed decisions and ensuring the safety of electrical installations. Remember that the NEC is a minimum standard, and in some cases, it may be necessary to exceed the code requirements to achieve a higher level of safety or performance. Always consider the specific circumstances of each installation and use your professional judgment to determine the best course of action. Electrical safety is a shared responsibility. Everyone involved in the design, installation, and maintenance of electrical systems has a role to play in ensuring that those systems are safe and reliable. By working together and following the NEC and other applicable codes and standards, we can create a safer and more sustainable electrical future. Always verify the specific requirements of the 2002 NEC document directly, as interpretations and applications can vary.